Okay, everyone. Quick test. Hold out your hand like this. I need everyone to tell me, how long is your desk? But here's the catch. No rulers, no tape measures, no tech. You have 30 seconds to measure your desk using only your hand as a ruler. All right, stop. Turn to the person sitting next to you and compare numbers. Did you get the exact same answer? Wait, how can the desks be different sizes? They're all identical desks. Did your desk grow? Did theirs shrink? You all just discovered the biggest problem in human history. Your hand is not my hand. In the past, units like fingerwid, ongul, fist, mushti, handspan, hast, and footstep were used to measure length. However, because age, size vary, the measurements taken by different people also vary. This is called non-standard measurement. Do you know? In ancient Egypt, the distance from a person's elbow to the tip of the middle finger was used as a unit of length called a cubit. Since this varied from person to person, the king's cubit was established as the royal cubit. Earlier, different regions used different instruments and units to measure distance, grains, and liquids. This caused significant difficulties in trade and other daily tasks. To solve this, a uniform system of measuring instruments and units was established for everyone. This is known as the Standard System, or the International System of Units, SI units. There are units for mass, distance, liquids, temperature, and time. Last year in 5th Standard Maths, we learned measuring time, so this year in science, we are going to cover unit of mass, distance, liquids, and temperature. First, distance. If I want to find out how tall this apple is, I don't weigh it. I measure its height. Next, mass. How much matter is inside this apple? Let's check the scale. Now for liquid volume. Take a look at this single serving milk cup. It holds 250 milliliters, ml. Finally, temperature. Let's check how hot this milk is. And that's all there is to it. Every day, without even realizing it, you're using distance, mass, volume, and temperature to navigate your life. Unit of distance is meters, mass is grams, liquid is liters, and temperature is Celsius, respectively. If 1 meter of distance is divided into 100 equal parts, each part is called a centimeter. 1 meter equals 100 centimeter. Similarly, 1 centimeter is further divided into 10 small parts. Each of these small parts is called a millimeter. 1 centimeter is equal to 10 millimeter. Some important points for measuring the accurate length. Correct position of the ruler. The object whose length is to be measured must be in direct contact with the ruler. The ruler should be held such that its starting point, the 0 mark, aligns with the beginning edge of the object. While measuring the distance between 2 points, place the starting point of the scale on the first point and observe which mark on the scale aligns with the second point. If the 0 mark or the starting point of the ruler is not clear, or if the ruler is broken at that end, start measuring from the next clearly visible number. By subtracting that initial number from the final reading, you can obtain the exact length of the object. Whenever a distance is measured, it is measured from a fixed object or a specific point. This point is called a reference point. While measuring the length and breadth of the playground, or length of the shirt, the difference of 1 or 2 millimeters is acceptable. While manufacturing parts of machines that match and fit together perfectly, their length and thickness must be matched accurately as per the requirements. One must make accurate measurements up to a much smaller range than a millimeter. Special instruments are used for such measurements. The factories that produce machinery need such precise and exact measurements. Such instruments are mainly used in industry. For example, a vernier caliper is used to measure length, inner width, outer width, and depth more accurately than a ruler. A screw gauge, also called a micrometer, measures very small diameters and thicknesses, like wires or thin sheets. The vernier caliper is great for small object dimensions, while the screw gauge gives even finer precision. Both tools help students learn careful measuring and accurate reading. To measure how hot or cold something is, we need an objective tool that gives us a precise number every single time. And that tool is the thermometer. So, why do we use thermometers? 3 big reasons: accuracy and safety. Feeling warm doesn't tell a doctor if your temperature is 98.6 degrees Fahrenheit or 103 degrees Fahrenheit. A thermometer gives exact numbers so doctors can keep you safe. Consistency. Whether you measure temperature in Japan, Brazil, or right here, 100 degrees Celsius is always the boiling point of water. Thermometers give us a universal language. Monitoring changes. In weather forecasting, cooking, or chemical reactions, we need to see temperature going up or down in real time. Clinical thermometer. How they work. Inside the glass tube is a liquid, usually colored alcohol or red fluid. When liquids get warm, they expand, take up more space, and rise up the tube. When they cool down, they contract and sink. The digital thermometer. When you put this under your tongue or armpit, a tiny electronic sensor inside the tip feels your heat. It makes direct contact with your body, does a quick calculation, and beep beep, shows your exact temperature in numbers on a tiny screen. It's fast, accurate, and super easy to read. Next, check out this one. It looks like a high-tech gadget. This is an infrared thermometer. That's right. It never even touches your skin. Every human body constantly gives off invisible heat rays called infrared radiation. This tool works like a superhero eye. It points at your forehead, catches those invisible heat rays from an inch away, and tells us your temperature in just 1 second. Anna Mani, 1918 to 2001. Anna Mani is known as the Weather Woman of India. F160C. She designed numerous instruments useful for weather forecasting. An instrument called a radiosonde is extremely useful for measuring atmospheric pressure, temperature, and humidity at high altitudes. Because of Anna Mani's research, the use of such instruments began in India. She conducted her research work at the India Meteorological Department in Pune and Bengaluru. Because of her contributions, India's dependence on other countries for weather forecasting was reduced.